Welcome everyone, and thank you for joining us on our webinar number 50. Today we are diving into one of the most overlooked yet most critical aspects of Power BI, performance. We've all been there. You click on a report and by the time it finally opens, you've lost focus. It doesn't matter how great your dashboards look or how advanced your calculations are. If a report takes too long to load, people just won't use it. Now, this directly impacts adoption, trust, and ultimately the decisions your business makes. Now, over the next hour, we'll explore practical ways to optimize your reports so they're not only accurate and insightful, but also fast and reliable, built to scale with your organization. Now, my name is Mark, and I'm a BI specialist at Zebra BI, and together with me is my colleague, Matej, and our team here, both him and I, we've helped many businesses make their reports more actionable and faster. Now, Matej will be helping me with your questions in the chat today, and later with the Q&A, so get your keywords ready and fire away. Before we dive in though, I have a short announcement to make. In less than 2 weeks' time, the Zebra BI team will be at this year's FabCon Europe in Vienna. So if you're also attending, make sure to drop by, and you can even book a short meeting with us if you want to discuss a certain topic or challenge you might be facing. You'll find all the information in the link in the chat. And okay, so with that out of the way, let's turn to today's topic, performance. So first we will cover the layers of performance and best practices. Then we will look at some real examples of performance improvements that we can learn from. And we will finish with some very useful tools if you're really serious about this performance thing. Now, followed, of course, by Q&A, and we'll see how long we can take it, depending on the time. And yes, of course, we will send you the recording and additional resources mentioned, including all the information on the tools used and so on. Now, before we give all our secrets away, we have prepared a quick poll for you, just so for us to see how much you really care about this, right? So I will ask the team to take the screen for this one, but I probably have to stop sharing. So let's do this. I think now they should be able to grab the screen, and let's see the poll we have for you today. Okay, so the question is, how long does your typical Power BI report page take to load? Less than 2 seconds, blink and it's ready. 2 to 5 seconds, just enough time for a sip of coffee. 5 to 10, starting to feel it. And I think there should be like, yes, of course, more than 2 seconds, 10 seconds, time to grab like a full espresso or lunch, or forever. You've never actually seen a fully loaded page before. So let's see some of the votes coming in between. Very good, very good. Okay, I'll keep the poll running for maybe a few more seconds just to get the feel of how you're all doing with your interactions and performance. So 5 to 10 seconds, yeah, that's still pretty heavy. More than 10 seconds, a bunch of votes for that. Okay, I can see that there's a lot of different experiences, but not many like really fast and snappy and like best practice experiences with performance. So I guess this is an evergreen topic. I'll just grab the screen now back. So let's share the screen again. And yes, let's dive into this and see what we can do about this entire thing. So, yeah, most of you seems that you have like on average, not too shabby, right? It seems that most of you know what you're doing, but let's see if we can give some tips to get even better results, right? To get in that upper echelons of performance where you're like really happy with how everything is responsive and like really having a good user experience with your users as well. But yeah, let's get serious now, right? So we want to go over the performance best practices, at least the ones that we found with our extensive work with clients, work best, and what we've learned so far. It should be really interesting. Now, in order to improve performance, we first need to understand a few key parts of the process, which are the source connection type and speed, and this is important, the type of the data model we use, and what we can do on the visualization layer to speed things up. Now, the visualization layer is maybe less important than the first two, but of course, we also need to then govern and analyze and optimize, right? And if we want to ensure this at scale, all of the parts are important, right? However, from our experience with many cases, most issues are heavily reliant on the first two, right? So the data connection type and the data model, especially the data model. So what we need to do is, of course, speed up both the connection, right, and the data model, right? So the source connection that we're pulling from, of course, the source itself is a huge part of this, but what we can control in Power BI is the connection and the data model. Okay, so first are the connection types, and they are quite different from each other in terms of performance. The fastest one, without any doubt, is import. You load the data once into Power BI. It makes use of the VertiPack engine. It's optimized for tabular models. It's super fast, in-memory database, has excellent compression, and so on, right? And you have like full control, full access to like Power Query, to DAX. But there is, of course, a data limit and the limit of how many refreshes you can do, right? You cannot have real-time intelligence on import. Now, DirectQuery doesn't capture the benefits of VertiPack, and you need to optimize all those queries on the backend. And even with all the optimization, you cannot optimize it to perform like import. Now, I will just quote Marco Russo, who is an expert in the field. I'm sure pretty much everyone in Power BI will know who Marco Russo is, but he's the guy, one of the guys behind SQL BI, and these are his words verbatim, right? Import mode is 10 to 100 times faster than DirectQuery, even after optimizations. You cannot optimize DirectQuery to perform like import mode. It's like trying to make your daily commute car go hypersonic. Not happening, right? So these are his words, the top experts that are like spending full time on performance, on DAX, on all these intricacies. These are the words. So DirectQuery will never be as fast as import, and it has other limitations in terms of transformations you can do, right, and so on. Then we also have live connection, typically to Azure or SQL analysis services. This used to be like the standard, especially for like bigger deployments. And on enterprise tabular databases, like almost as the same one as in Power BI, right? And those are typically fast, right? It's really scalable. But of course, there's some limitations on what you can do then from the Power BI side of things. You have to build the models in analysis services and so on. And last is the type of model that is more and more common, and it has been getting some quite improvements, and these are composite models, right? And those can actually combine different types like import and direct query, or even direct query, direct lake, right? So the data lakes and so on are getting really popular, right, these days. And you can make it to be really fast, right? It's really a flexible connection type. And you would, for instance, have like some of the tables, or the majority of one, on import, but then where you only require direct query on a specific table, you would use that one. And if the requirement is real-time data or like refreshes, this will almost always be preferable to direct query. So in terms of connection types, import mode is the fastest one for performance. Now let's move to the number one reason why your Power BI report is slow. And this is a messy data model, right? Data model is probably the most important thing to make sure that you handle it correctly. And this is an example of such a model, right? It's all tangled up. We have multiple fact tables, cross joins, tons of joins, bridge tables, then connecting different dimensions to facts and to other facts. And this will inevitably lead to complex DAX formulas, many-to-many relationships, which are very, very expensive in terms of like drag on your performance, unused columns, DAX measures, and even tables, right? Bloating up everything. And naturally, this will be very, very slow. And this is a real life case of a data model. And the good news is this can be transformed into a proper data model. Even if you inherit such a model, it can be transformed. But yes, this will typically be the biggest drag on your performance. And whatever you do on the front end, whatever you do with the connection, if you have a wrong or completely garbage data model, you will not be able to have fast reports and a good experience in Power BI. So, and the key reasons for this kind of data models are as follows. So lack of proper data preparation and ETL, separated like fact tables and multiple of them. So you need to kind of do these joins and so on. Lookup tables instead of like proper hierarchies and dimensions, right? And including all possible columns instead of only required ones. So the requirement comes typically for business, right? You want to do a lot of different stuff, right? That there's a lot of, and you want to give the full flexibility to all of your users, especially with larger deployments, right? You need your data model to be flexible to do all of this. But this is typically where it's really, really important that you do proper planning with the business users at the start before you start bloating your data model with things that in the end will never be used, right? And this can have really, really, really big impact on your performance. And of course, with large deployments and this kind of data models, this will also lead to unnecessarily complex row-level security, right? Which again can be a drag on your performance. And this forces you to use really complex DAX expressions and bridge tables and many-to-many tables, all the bad things that we mentioned before, right? So this kind of data modeling, we actually call data knitting, not data modeling, because you're just taking all these connections and strands between tables and just trying to make it work, which again, in the end, will just result in a big ball of mess. Now, the alternative is, of course, to look at some proper data models, right? And these are I'd say the more common ones, right? So either you use a flat table, you build a star schema, a snowflake, which is basically a star schema expanded with some dimensions, and this can work. And of course, the messy data model. Now, the winner in Power BI is, let's hear it, drum roll, it's the star schema, right? It's the tried and true best data model. And yes, flat model can be faster with extremely simple queries, right? There's been some debates in this regard as well. And here's a link to the article that actually compares the two data models, so you can check it out in your own time. But as soon as the queries increase in complexity, the benefits of the flat data model fade away very quickly. If the query is not pure storage engine query, the star schema model performs much better in 99.9% of cases. When it comes to retrieving values from the slicers, the flat model is extremely slow. The important takeaway here is the following. When the flat table is better, it is not that much better, right? But when it's worse, it's far worse. And in all practical deployments so far that we've seen, the star schema was clearly the best choice in Power BI. But yes, this means that you have to prepare this lean data model, which is the star schema. And these are like the important parts of it, right? So the star schema, we have one-to-many relationships from the dimensions tables to our central fact table. We only have the necessary elements, and this enables us to have simple DAX and have fast data modeling and Power BI reports experience. And this is a real case, exactly down from that messy data model that we saw before, right, to 8 tables. Okay, so if you want to have performance reports, there is no avoiding this. You need to do your data and model preparation. You need to append different fact tables into one main fact table, transform your hierarchies and attributes into a single dimensions, and filter out any columns that will not be used. Any columns should ideally be filtered out. Now, you can do this either in Power Query or ideally even at the data source, right? And for some specific, of course, measures and calculations, you can do it in DAX, right, later on. Now, this would be the typical example of a star schema, right? So we have a central fact table. You can include measures in the fact table and hide all the rest, right? Or you can even create a separate table just for the measures, and that will also be a good way, right? But you can then structure it in folders and so on. We want to hide all implicit measures, right? So implicit values, or even like disable them, and I'll show you how to do this later, and use only explicit measures. Now, we also hide the foreign keys, and we want them to be on the integers, right? So number type columns should be the ones to use for these relationships. And if possible, should be as short as possible. Again, we hide them, and we also want to reduce granularity here. On the dimensions, again, we hide the foreign keys, and we only display and use visible and necessary columns by which we will filter the rest. In the calendar table, we also, of course, want, like, ideally, we want to have a calendar table. And here, it's actually preferable to use a date time column and mark as such. And I'll also explain this. And we want to avoid as many calculated columns as possible. And the last thing is, of course, yes, one-to-many relationships from the dimensions that are small, short, and narrow, and we will filter the main fact table where all our data and metrics will reside. Now, I'll show you also one thing that is important here and can result in really bad performance if we keep this unchecked. For some reason, in Power BI, if you have a calendar or date table, date field, Power BI will automatically generate calendar tables behind each date field that it will find, right? Shipping dates, sales dates, and so on, order dates, all of those will generate individual calendar calculated tables. And this can really slow down the entire data model or even crash the experience for like many users. So the first thing we actually recommend in Power BI is to go into File, Options and Settings. And here we want to first turn this auto time intelligence. So we go to data load, we turn this off. This will be on by default. And it's, I mean, it's good if you have a simple file and you just have one date field and it will generate some calendar for you out of the date field. So you can basically use like the typical time intelligence and year, month, and quarter fields. But this ideally should really your models should be turned off. And even in the current file, right, we need to just turn this off. And it's best to then mark your primary calendar table as a dates table and mark the primary date column for which you will do time intelligence from. This ensures that you have like just one proper calendar table and you're not bloating your data model unnecessarily. Okay, so let's return to the presentation. Now, the next thing that is really, really important that we want to do is we want to push calculations upstream. And this is an excerpt from Matthew Roche's maxim of data transformation. Those of you who don't know who Matthew Roche is, he's a member of Microsoft's CAT team, and he's been in data longer than, I think, longer even than I'm on this planet. So he's kind of a, let's say, authority in this regard, right? And his maxim states as such: data should be transformed as far upstream as possible and as far downstream as necessary. Now, when you're deciding whether to use DAX or Power Query, whether you should do it in DAX or Power Query or at the source, right? Note this, right? Performing data transformation in Power Query ensures that when your data is refreshed, the data is loaded into the data model in the shape it needs to be in. Your report logic will be simplified and thus easier to maintain, and will likely perform better because that Vertipack engine will need to do less work as users interact with the report. If you need the data transformation logic that depends on the context of the current user interacting with the report, things like slicers and cross-filtering, this is the perfect job for DAX measure, because Power Query doesn't have access to the report context, right? So implementing this logic farther downstream in DAX makes sense because it's necessary. Okay, so what then to do with like a calendar dimension, right? Should you generate it in DAX or Power Query? Typically, it would be best to do it in Power Query or even at the source, right? Much better than having it in DAX, as it then won't consume time to evaluate on every interaction. Okay, so from a performance perspective, it's always better to perform a given data transformation as few times as possible. It's best to not need to transform that data at all, as data transformation is a costly operation. But sometimes you cannot go all the way, right, to the source, but just do it as far as you can. Now, let me show you an example where you can actually check if the query itself is folding back to the native SQL query source, for instance, in Power Query. So if we go into Power BI and in transform data, we can actually check if we can see the native query, which means that the query is folding, right? So here I'm connected to a SQL data source, and on the steps for this particular table, right, I can actually right-click on the steps, and if I see view native query, this is a good indication that this will actually fold the query back to the source, right? So we're doing we're reusing the fast SQL query that can be generated out of this. Now, some transformations will actually break this. So for instance, if I change this column into a different type and I try to view native query, you'll see that I actually cannot see this query anymore, right? So it might be an indication that the query folding is not happening anymore, right? It's not necessary, but this is a good indication, right? I won't go into too much details about this, but this is a quick way how you can see if you're actually leveraging the speed of native SQL queries in your tables. Okay. So next is row level security. right? This can also be a performance killer. And in practice, we see that some of the rules are important to follow. And again, as before, star schema is a must for efficiency, right? If you want to have a fast and efficient row-level security application, you should use the star schema data model. You should simplify rules, right? So no lookups, no joins, apply only to dimensions if possible. Use the user principal name instead of hard-coded names for consistent user identification. Don't create many redundant roles with similar logic. Don't rely on bidirectional relationships for filtering. But instead use like security groups for large deployments, right? And this can be then added and so on. There's also, of course, an option to consider alternative designs, right? Where you actually split the data model and reports for different audiences and publish to separate workspaces. Now, important here is that you should always test the rules using view as role during deployment, and of course, optimize the model first. So in Power BI, right, if you just want to see how a certain role is used, you can actually go to the modeling side, and here you can just use view as and then select the role that create for your row level security, right? And then you can also test it. We'll see later on just how to do that as well. Okay, and if the row level security becomes too complex to maintain or slows down your reports noticeably, maybe yes, this alternative design is an approach that you can use, right? To rethink the model architecture or user segmentation. I know this might come as a bit of a surprise, right? But sometimes just using separate reports with workspace level access control is more scalable than having like one report for all users and then applying this row level security across the board, and it will inevitably be slow, right? So sometimes it's better just to publish for that direct level of access for that user group. Okay. So to recap, how to speed up the most important part of the puzzle for performance. First, choose the right connection. Next, of course, do your data prep. Implement a star schema data model, which is efficient, which Power BI is optimized for. Push the calculations upstream. Try to do all the calculations as further upstream as possible, and as downstream as necessary, and simplify row level security, right? Avoid some overcomplicated roles and so on. Okay. Excuse me. So now let's take a look at what we can do on the visualization layer, how to speed up the reports and visuals. Now, the number one issue we still see way too often is too many visuals per page, right? And this is really important in terms of the visualization layer. Each visual actually will have its own render time. And the one reason why we see this kind of reporting is this, right? So the typical one-size-fits-all report design, right? We have a ton of visuals because we want an excessive slicers, right? Because we want to cater to too wide an audience. And then we find ourselves with all these problems, right? Tons of visuals, excessive slicers, and even if the slicer panels are hidden, you then are basically just leveraging that real estate of the report instead of like showing the insights. And we are visualizing way too many data categories per page, and it's just visual overload in terms of grabbing the attention, but also in terms of performance, right? And then we add tables with too many levels of hierarchy, which of course, again, will require complex row level security, right? So let me try to explain this inside of Power BI, right? How you can incorporate some of the design layout into the backgrounds of pages, because each visual, even if it's an image or a design layer visual element, has its own render times, and not all of them can run in parallel. So let's go into Power BI and just see like a report, okay? So in the View tab, if we open the Selection tab, you'll see all the objects on this page. And now each and every object, right, that you select, each of these objects will necessarily have its own render time when we analyze it. Now, this report and model is optimized, so naturally, right, and it's even a subset of the data, right? So if I refresh the visuals, it's still going to be moderately fast, right? But again, you see each and every object has its own render time. And if I expand it, right, you will see that most of the time, it's not even the time is spent on the DAX query or the visual display, but it's actually the visual is waiting for other visuals to load first in order to basically display itself, right? So each object that we add to our report pages will have this render time, and it will slow down your report. So what we want to do, what is the solution then, right? What we can do is improve our dashboard layout design pattern, right? So we want to include the right level of details and the right level of objects per page on our reports. And of course, the landing page should load really fast, but for this, it needs to have a really limited amount of data in terms of display, right? We don't want large hierarchies, many objects, maybe 4 visuals, and that will do. But then later on, when we do the exploration, we want to expand to like detailed pages, trends, and so on. And this will actually segment the report or dashboard or app that you're building into manageable chunks for Power BI. And it will ensure a good user experience with fast loads on the homepage. Now, I mentioned consolidating your visuals, right? That each visual has its own render time. It's really important if we have access to, we want to reduce the visuals per page, but that does not mean we need to reduce the information per page, because as it so happens, we can use small multiples and multi-card and multi-chart visuals within Power BI, right? And these can help us even improve our performance in the end. So instead of having all these objects, we can actually leverage just a few of them, right? So we can leverage a multi-card visual. In this case, let me just show the data a bit. This, right? So we can leverage a multi-card visual, right? So, and this gives us even more options, right? Because I can now filter the data by filtering the cards, right? And again, it will trigger, of course, these refreshes, right? But it's much more efficient, right? Because when you refresh the page, it's just refreshing 3 visuals. So we have a charts visual here, we have a tables visual, again, which has a lot of information, but it's all condensed into one table, right? Many columns, even including visualizations. We recommend like using less hierarchies, and then when you need to expand, you can drill down into specific items, but it's better than having like a deep hierarchy of like 20 levels to incorporate maybe report page tooltips, right? So when you need further breakdowns, you can just hover over the elements to provide more insights on that same page. And again, the report page tooltip itself will only load and trigger the query when you hover over that particular data, right? So it kind of segments all these loads on your user experience at that point, right? This can be really, really fast and performant and efficient, and you can use the Power BI interactivity to then combine and cross-filter the rest of that information. And lastly, with this kind of like multi-card visuals and so on, you can even drill through directly into the details from this from the KPI itself, right? So this means that I don't have to like include all of this information on the main page, right? I can have detailed pages separated in other pages, and this will make it a much better user experience because you can segment and pre-filter the data, but still, of course, have like really detailed information on like all KPIs, on different trends, and we can leverage small multiples for trends and then like reuse some of the charting elements really easily. And just, you see, the interaction is really, really fast. It's snappy. It doesn't load for ages, right? And we can, like, if we take this up a notch, right, we can have like on detailed pages, like really deep hierarchies, right, as well, where you can just expand, collapse on certain items. And you can even display like multiple charts, like hundreds of charts in the same visual, right? It's just one object. Again, like even if you have like multiple reports open here, you see it's still pretty snappy, right? It works. You can work with this instead of just having like each and every object or like 100 different object charts, and each needs to render in its own time. Okay, so yes, one way is to actually consolidate this visuals, and for this you can use the small multiples. Now, how you can use small multiples, I think this has already been also added in many visuals, but in Zebra BI, basically, all you need to do is when you build a chart, right, you simply drop a dimension into the group's placeholder, right? And this will now naturally build all of these charts within that same visual. So it's one render time. If I check the performance analyzer here, right, I start recording, refresh visuals. It's one render time for this particular visual, right? And I can display like 10 charts, and you can even like increase or decrease the number of charts and focus on what's important, right? And this is really also a very good visualization concept, right? When you're trying to understand trends, longer term trends, and how they correlate to each other, you also want them to scale properly, right? So you can grasp the importance of each individual change and so on, right? And all of this can work really, really well in terms of just the design layout and how you tackle this from the visual standpoint. Okay, and then we have some specialized cases, right, where you can use specialized tables which actually allow you to define your loading strategy on the front end of the visual, how you want to basically load it. Do you want to load the entire data set at the start, which can be useful for direct query, right? Because each and every subsequent change then will not again trigger the query back to the source. So this can be a good solution. Or you want to just display and query the visual state, right? So if you have everything collapsed, the initial load will be really, really fast. Now, we have a really good example and real case with a customer where just this simple change actually reduced the load time of the entire report page and the tables from 50 seconds, more than 15 seconds, down to under a half a second, right? So, but again, still you have to be reasonable with expectations, right? With DirectQuery, you will never be that fast, right? But improving interaction, load times below like 3 to 5 seconds. This is doable even on DirectQuery. Now, there are still limits how much data you can display in a single visual, right? But overall, these options just help you get better results for different connection types. Okay, so to recap the key points for optimizing the visualization layer. First, use an efficient report layout, right? This overview to details, to trends, and so on, like more of an app-like experience. This is typically the best way how to compartmentalize the different levels of reports to not have those heavy loads on like one master page that incorporates all. And then you have to like basically filter out through row level security and then different like slicer panels. And before even the report is usable for that user, they have to preset like 20 buttons, right? This is also bad design in terms of design in general. Next, we want to, of course, design a clean landing page where, you know, it has this initial like fast loading time is just like aggregated values, overviews with top and plus others functionality and so on. Okay. Then we can delete all decorations like lines and logos and incorporate them into the JSON theme, right? So you can actually incorporate those design elements into the theme of the report so they will not trigger those separate loads on each interaction. And yes, fourth is consolidate all visuals, right? So replace separate charts with multi-card visuals, replace separate charts with small multiples, or replace tables with cross tables, right? That has many different groupings of tables. You just use the grouping functionality there. Now, report page tooltips, again, and drill through can help you very, very much, like to not even have to leave the page, right? The report page tooltips allow you to actually filter, drill down without even leaving the page. And then, yes, if you need to go into more detailed analysis, like for deep dives, you can, of course, drill into specific elements. And lastly, of course, reduce numbers of categories per visuals, right? And avoid deep hierarchies. Okay, now let's take a look at some of the tools to help you analyze and improve performance. Now, these won't be deep dives, as each tools could actually warrant a whole session on its own. I will just try to showcase the tools we and our customers have found most success with so far. Now, before I jump into the tools optimization, we also have another poll for you. So I'll just, again, give the screen back to my colleagues here. So for us to see how familiar you are with the tools that we are using here. So the question is, do you use any of these performance optimization tools within Power BI? The first one being Performance Analyzer in Power BI Desktop, then Best Practice Analyzer within a Fabric notebook for semantic models, DAX Studio, Tabular Editor, it can be free or paid, Measure Killer, free or paid, or any other tool of choice that you have. And yeah, I see that we have some people who've never heard of this before. A lot of you kind of know Tabular Editor. That's really nice to see. Performance Analyzer, hopefully, I'd hope this would be more easily discoverable. So let's see some of those coming in. Okay. About like 30% of you know about the Performance Analyzer built in Power BI Desktop. Okay, that's encouraging. But yeah, okay. So let's take a look at those tools, right? So I'll just let's reshare my screen and let's which of tools can be really helpful. Like all of them have their own place, right? But there's slightly different purposes in what. Oh, sorry. I think the screen sharing didn't go through. So let's try again. Okay, now we should be good to go. Okay, so yes, the first one is of course performance analyzer. We've already seen this, so it's the native option, but you can combine this with DAX Studio, right? So how to actually go deeper than just these initial timings that you receive from the performance analyzer, right? Because first of all, when you're doing this performance analysis, right, in performance analyzer, you'd actually want to start first of all from a blank page, right, so that you get this initial performance timings, and then once you
Hey everyone, I'm sorry. I guess Mark has some difficulties with his connection. He probably logged out and logged in again. Stay with us for a couple of minutes and hopefully he'll be back soon. Okay, Mark, can you hear us?
So just give me a second. Hello?
Hey
Can we hear
Mark,
each other?
glad to see you back.
Yeah, can we hear each other or?
I can hear you. I can hear you.
Okay, yeah, okay, then it's good. Yeah, the irony, talking about performance, and then I have a random Microsoft update on the computer during the webinar. That's life, right? Okay. Yes, so thanks, Matej, for jumping in with the questions. Let's see now where we left off, right? We were talking about tools to use for analyzing and optimizing your performance. Okay, so let me just share the screen again. And let's go take a look at DAX Studio. Process or help you with the query, you can download DAX Studio. It's an external file, right? But then once you actually have started the performance analyzer, right? So when you start recording, press the visuals, and you want to get the query, right? You take this query, and in external tools, right, you open DAX Studio, right? And this will bring up the program. Sorry, but I think we don't see. Do you see the screen? Not yet. Okay, let me just reshare again.
Mark, we don't see your screen. You're also breaking up a little bit. Maybe
Okay.
it's I can hear you well now, but I see your Wi-Fi signal is dropping from time to time. So
Okay.
something will be unclear. I guess we'll probably record again and on our own and then stitch something up. But yeah,
Okay. Yeah, for sure. For the recordings, I will break it up. Okay. Now you should see the screen. Okay. So once the DAX Studio is open, right, you have the selection of that data model if you open it from the inside Power BI, and then you can go here and toggle query plan and server timings, right? And this actually gives you the ability to now query that and record both for that DAX query that we copied, right? So we go into Power BI, we copy this DAX query, or you can even export the entire thing, right? Whatever you have in Performance Analyzer for multiple visuals, and you can then just import it here, right? And then you can run the query that you've just exported. You should see the query plan, right? For that query. And then also the server timings, right? And here you will capture the time spent in Formula Engine and Storage Engine, within DAX Studio, so you can basically compare and analyze anything that you will optimize within your DAX measures. Okay, so DAX Studio can be really helpful when you're trying to like get this analysis. You can export it, and you can even like test it with different roles and so on, right? So when you're doing this, so this is a really helpful tool when you're trying to understand the intricacies and the timings and so on. Now, next is a really useful tool for everyone who's working with like Tabular and Power BI semantic models. You have Tabular editor and the built-in best practice analyzer. Again, this is an external tool that scans your data model against a set of predefined performance rules, but you can even like customize those rule sets for your data model. And again, here you will just open this once you, of course, install that Tabular editor. You can open it from inside Power BI, right? And you can do like different model transformations, right? It allows you to also access C# scripting language, and then like do. You used to be able to only do calculation groups from inside Tabular editor. So a lot of people who are a long-time Power BI fans will typically know about this tool, right? Because before some things like translations and so on weren't even possible to do outside of this tool, or it was really hard. Now, below here, you can see that we actually have an indication of best practice rules or issues covered for this report, right? And if you click on this, you will actually get a pop-up for all the possible things that can be wrong with your report, and you can like even collapse and see which are related to performance and other objects. And then for specific rules, you can actually either use this icon here to generate the fixed script for that rule and apply it here directly in Tabular editor. And if you hit run now, okay, it will apply this rule, and as you see, as the fix has been applied, it will also remove it from this best practice violations, right? But for some of the rules, right, you can even apply that fix directly, right? So if you want to see what you will be doing, right, you can just paste it as a C# script. But I can just walk through this and apply and basically fix some of the issues that I have with my performance, right? And depending on like the severity, you can do this. So this is really useful if you want to analyze, automate, and just clean up your model according to the best practice rules set by some of the leading BI experts in Power BI from Microsoft and from the community, right? So these rules. You can find those rules actually on GitHub and go through the entire list. So this is a really useful tool that you can just leverage, and it has this built-in best practice analyzer for your reports. Now, next are two really modern ways of actually controlling a lot of things in Fabric and semantic models and so on. And those are Semantic Link and its extended library, Semantic Link Labs. Now, I won't go over all the details what this is, right? You can scan the QR code here to learn everything about it, or just read this in the recording, right? What the reasoning is, right, behind Semantic Link and Semantic Link Labs. But basically, this extension are open source Python libraries developed by Microsoft and some really smart people from the Power BI community, spearheaded by Michael Kowalski from the Microsoft CAT team. And what they've done has unlocked some scenarios that were before even unimaginable, right? automatic translations of entire semantic data models and like migrations of large data sets and so on. Some of them are related to performance, but it goes just beyond that. All you need to know is basically, you don't need to be a Python expert to use Semantic Link or Semantic Link Lab. And the helper notebooks are really, really useful. Right, so there's a whole list of helper notebooks that's constantly being expanded upon. You can see the list on the right-hand side here. Sorry, let me just turn off the echo for a bit. So yeah, like this. Okay, and in this list, you'll find like different scenarios that you can cover, right, related to performance, how to do best practice analysis, and so on. But you can actually access the Semantic Link Labs and some of its functionality for performance naturally through Power BI service, right? So if you go to your Power BI report in the service, right, you can go here and view the semantic model, right? So on the report, if you have access, you can actually view the semantic model, but let me just see why I cannot let it refresh here. Okay, BI test environment. Nope, not. Let me just get. Okay, sales dashboard, semantic model. Okay, yeah. Okay, so you click on the view semantic model, and up here in the ribbon, you will find the link for model health. And in here, you actually have the notebook, which calls the best practice analyzer from Semantic Links. So I can actually generate this notebook, okay? And it will generate me a notebook with the best practice analyzer from Semantic Link Labs imported into the notebooks, targeting that specific data set and workspace. And all you need to run now to do here is now run this, right? So you can run this automatically on any of your semantic models, and it will give you like the full list and breakdown of like everything that you can do within your semantic model. So it's now importing that Python library, is running the best practice analysis similar to the one that we used in Tabular editor. And you can do this on a large scale as well, right? So in the end, it will give you like the list of errors like DAX expressions related to formatting, maintenance, and of course also performance. And you can go through each of these sets, and you can even write this into a specific report for all of the reports, right? So this, I'll have to wrap up because of the little time skip that we have there. But basically, you have helper notebooks that allow you to automate the entire process of running this scan for the best practice rules that you set, do it bulk for a single workspace or multiple workspaces, or even all the semantic models accessible within your Fabric workspaces, and then generate a report out of it, so you can track and analyze and see the model health on the enterprise scale, right? And here are just some of the cool scenarios that you can do with Semantic Link Lab, right? So basically, yes, the one that we saw, you run the DAX expressions or the model best practice analyzer, and you can just go through entire thing on individual model level. Because of LLM support integrated and Copilot, right? It also supports instant translations. So all you need to do is basically just add language, and you can even query it in natural language, like you can translate the results of these and like just the model names and everything in any language that you want, right? You don't have to know Chinese or Italian. It will just run these translations in the language and the analysis in the language that you want, right? So it's really, really powerful. And this is not just for analysis, right? It's also for generating those translations and changing the data and so on. So it's really, really, really powerful. You can again, as I said, you can also do semantic model translations. So you basically instantaneously translate into any language. And this was previously, I mean, you could spend days and days and days of like a whole team of people could spend days and days just doing manual translations by hand. This was impossible to do on a large scale, but now you just simply write in the language and it will translate the entire data model, the entire report on the spot, right? So this is a really, really powerful tool that I highly recommend looking into, not just for performance, but also in terms of like, yeah, doing vertipack analysis, translations, migrations of tools, right? It can access all the information that you also get in DAX Studios, right? Vertipack and analyzer like this. So a really, really powerful tool to use on top of your Fabric data models, and it's available natively, right? You just import that GitHub Python library, and yeah, we'll share the resources if you're really, really interested. Now, the last tool I want to mention here, and it's really, really good for if you just inherited a data model, right? If you're working with larger data models, I highly recommend checking out Measure Killer, right? It has a free and paid version, right? The free version can be used like for single model. It's an offline tool, right? So this scans your Power BI files and show you exactly like which measures, columns, or tables aren't being used in your report. It's a great way to slim down your file, like reduce memory usage, all the things that we said at the beginning, and speed up performance, right, without guessing, right? So it has the built-in functionality to do analysis for you, and it's super handy before finalizing or publishing your reports, right? So also it has some built-in like nice gamified features, so it makes cleaning these reports a bit less of a drag, right? So, built into some of the operations. So let me check if we still have time to show this. Yes, maybe 5 minutes. Okay. So I'll go into, let me just open the report and let's try to run Measure Killer on this one. Okay, while this is opening, I'll also mention Measure Killer tenant analysis, right? Now, this is a paid version of this tool. But if you're really serious about enterprise scale performance optimization, I would recommend checking it out, right? There's a free trial that you can check out, and it includes full tenant analysis, right? Including personal workspaces and even automation scenarios. So it's not as diverse as Semantic Link Labs in what you can do with this, right? This is strictly for performance and analysis of your objects within Fabric, but it's still very, very useful, right? So this would be like an output, right? You would get all your reports and semantic models. You have different views, right? For Power BI reports, for data flows, DAX expressions that are used like across the workspaces, and it will easily like just give you just run it. It's super simple setup. You select the workspaces, select the permissions, and just hit run, and it will do the full analysis. It will assess your reports and like give you like best practices score, right, on individual reports. And so like if you're responsible for I don't know 10, 20, 50 reports, right, you can easily just scan them and even automate the results and export the information and details into like a Fabric notebook and so on. Okay, so let me just see if I can run the Power BI, the Measure Killer tool. Well, it seems it's currently not letting me to do so, but basically, yes. In the interface, right? You select it. You can clean up automatically, right? Some of the tools, right? You can do a easy like one button kill all unused columns, all unused measures, or there's an alternative option when you need to kind of have more control over what you want to exclude from certain tables, which allows you to just basically copy the query for Power Query, and it will simply end on the end of the step, right, in Power Query. It will, sorry, let me use this report. So when you go to Power Query, it will allow you to use the advanced editor, right? So when you go here, you can use the advanced editor tool here, and you will simply just paste whatever the expression measure killer puts here, and it will basically just add a step to remove all unused columns, right? So you can easily just check on uncheck. There's no like irreversible steps, so you won't break anything. And you can actually run it many iterations through the reports, right, to see. Because it also checks like for filters, if the field is used in filters, or in another measure expression, and so on. So it's a really useful tool to do. Now, unfortunately, we have kind of run out of time. So yes, let's close with the recap of the recommended toolset. Starting with the recommended toolset. So Performance Analyzer plus DAX Studio is really good for runtime performance diagnostics, checking the details for like DAX queries and so on. You can use Tabular Editor for like manual or model scripted edits, and automatic best practice validation, plus some like cleanup, like with the easy buttons. You just hit the fixes or generate the script so you can check it out. For automated metadata analysis across like all the Fabric models and workspaces, Semantic Link Labs is definitely something to check out. It's a really cool project, and like I can see it being used more and more within the community. But yes, there's some really good use cases also for like understanding performance, analyzing, and then of course fixing the problems. And lastly, of course, Measure Killer, easy tool, easy setup for cleanup, reducing model bloat, and of course full tenant analysis. Okay, and finally, let's recap with everything that was shown today. First of all, to handle performance, we have to choose the right connection. Then we need to set up a scalable star schema data model, use a performant design layout and visuals that help you, of course, get the most out of the visualization layer without like unnecessary waiting for all the objects to be rendered. And in the end, we can use some very good tools to analyze, monitor, and of course, optimize the entire thing for scale up, right? And by following these steps, you will ensure a robust reporting structure that will perform to modern standards and your expectations. So that are our recommendations for performance. As said in the beginning, if you wish to discuss any of this and see how this works in action, what you can do, what are like some of the challenges that you're facing, and if you want to discuss those, we will be at FabCon Europe in Vienna in 2 weeks, and you can hit us up at booth number 32 or schedule a session in the link in the chat. And yes, if you want to try out Zebra BI visuals on your own, you can scan this QR code. I'll give you a few seconds, but again, we will send you the recording, so don't worry, you can check it out or go to zebrabi.com, and there you can try the visuals for yourself. Here are some of the resources we've had we are constantly running live demos of Zebra BI with Q&A, so you can also attend those if you're more interested in the visualization part of the tools. We also have a Zebra BI Academy. It's a self-paced learning platform that you can use to learn more about actionable reporting, not only performance, right? And we have other webinars for different topics on financial reporting, on all sorts of adoption challenges and so on. So yeah, there's more than 50 hours of webinars that you can always access on demand on the website. And you can check all of the Power BI templates that have been shown here, the Zebra BI ones as well, on zebrabi.com/templates. Now, without further ado, let's finish with the Q&A, or if some questions were left unanswered. So let's see.
Yeah, hi again. Yeah, I think we covered most of the questions, but not to full extent, because I was always waiting for you to come back and didn't dive fully into it. Basically, none of them. So we'll follow up in the
Yes,
the emails afterward. But I see we have some new questions, so I'll just post it up. Okay.
Okay. Let's see.
This is an interesting one, I think. Let's try to answer this one.
I had a Pro license and the report on Workspace which used to refresh fine, but recently moved to Premium license and since then facing memory issues with refresh of the same report. Would you know what that happens? So I'm guessing this is a question regarding the switch from the Power BI Pro license to the Premium license. Now, yeah, that's actually a good question, right? Premium capacity can have shared resources, right? So it can impact your performance negatively if there are other users on that capacity that might be slowing down the entire thing, right? So it depends, right? Here this is like something that's it's case by case. It depends what was the situation there. But yes, this is a valid scenario, and it can happen, right? I see there's another question. When creating summaries, is it better to create summaries using DAX tables or create summaries using Power Query? In general, the idea better, faster visuals. Power Query, right? If you can do and summarize data in Power Query, it's better than in DAX, right? Because it will load beforehand. This was the concept of pushing the resources or calculations upstream, right? We talked about this in the first part of the session. So ideally, all calculations or all aggregations should be done as close to the source as possible, right? Of course, sometimes you don't have access all the way down to the source, but if you have access to Power Query, do it in Power Query. If you have access to SQL Server, yeah, it's maybe even better to push it there, right? But yes, for some cases, it's like for interactions and controlling the interactions, a DAX calculation would work.
Okay, good, thank you. We'll have two more, I guess. Let's go with this one. So how did you manage to reduce that messy data model from 32 tables to 8 or so? It's a common issue and data model is hard to understand and edit.
So yes, that's actually a really good question. Okay, so first of all, you need to sit down with the business users and the requirements, right? What do they actually need to see? But then, yeah, you simply find out that it's not necessary to keep like all the dimensions, right? So some of them have not been used, and you can check for those that are even not used in the report with the tools that we mentioned, right? But then, yes, once you pinpoint the requirements, what is the actual need and the insights that the report needs to see, there is much easier to then structure the dimensions and the fact table in a way that you only include what is necessary, right? And yeah, strip it down to the bare minimum and then build on top of it, right? Scale up later rather than just have a Lego playground of all the possible BI objects that you can, right? So it's much more scalable. It's easier to maintain and see, right? Start with the requirements and the insights, right? And then when you get further questions, yeah, you can build up and add more objects as the project grows. So that's typically a much better approach than to just think of it as self-service BI. I will give everything to my users and they will figure it out. This approach in most cases doesn't work. For exploratory dashboards and stuff like that, yes, but you can do this, but it's a completely different concept, and it has to be, again, still maintained with good oversight of the entire data model. I see a question with Python codes run in Power BI Desktop. You can run Python within Power BI Desktop. That's true, and even R scripts. So there's a visual to do this, right? There's actually two native visuals to do this, but for this model assessment and semantic link labs, you actually need to be on the service, right? In Fabric and run those. At least at this point, right? It might be that at one point you'll be able to run it from the desktop and call it like similar to what you can do with Tyndall view, right? You can now control the tabular model directly in Power BI Desktop and just switch objects and control it. So hopefully, yeah, maybe you'll be able to run semantic link labs directly in Power BI Desktop.
Okay, I guess we'll take one more. I guess this is a good one. We had discussion in the chat about fact tables. So many of those. So there were arguments.
Yes, correct.
I mean, and yeah, sorry, go ahead.
One fact table is not like, you can have like multi-fact table, right? And have multiple star schemas within your Power BI, right, model and so on. But in terms of like, how do you want to structure it? It's maybe better, and this is the business concept, right? So typically where we see this multi-fact table and it could be cleaned up and it's not necessary is where you have like a separate fact table for your actual data and a separate fact table for plan or historical data or archive data. And those can actually be combined rather than have them separate, which would then require multiple connections and so on. So ideally, if at all possible, combine and consolidate all those into a single fact table. And we actually have a full webinar on this, like how to do it for financials, but also in our knowledge base, you'll find how to basically do this for like these typical business scenarios, like plans, budgets, forecasts, archive data and historical data. These can actually be combined into one. But yeah, sometimes, yeah, you will have multi-fact table, and that's fine, right? But in best case scenarios, each fact table would result in a single star schema. But yes, multiple star schemas can be used within the same report for different purposes, or different or an app rather in Power BI. Okay, I think we've almost extended all our time. Hopefully you've found some of the things here useful, but otherwise we'll share also all of the resources, also the tools that we mentioned, right? If you want to go deeper and really play around with those tools yourselves and see how they fit into your workflows, You can check those out in the follow-up email. We'll send you the recording. We will send you the Power BI files. But yes, thank you, and see you in the next webinar.